All right. Here's a question from section 4, chapter 11, section 4, number 6. And this is one of those other particular ones, similar to the ones in chapter 10, where we're dealing with two proportions from dependent samples. So it has a little bit different formula that StatCrunch won't do the actual formula for us. We know it's dependent because they're asking the same person first if they're happy or unhappy, and then if they're healthy or unhealthy. So that makes it dependent samples. And so between two proportions from dependent samples. So we're looking at A. And then to find the alternative hypothesis, the null and alternative hypothesis, it's always first that they're equal to each other. And then they want to see, are healthy people also happy people? So are my proportions the same? Not that one's more than the other, just to see if they're the same or not. So this would be my null hypothesis, where my alternative is just going to be that they're not equal to. So this one's also A. Now when computing your test statistic, if you just looked at the number of healthy people out of our total versus the number of happy people over our total, that would be comparing two proportions if we were looking at independent samples. Since we are looking at dependent samples, we have to use a different formula. So again, what you might get lured into doing on a problem like this is going to your stats, figuring out your proportions of two samples with the summary. And so you could say your number of successes for healthy, we'll say, would be 2,579 over whatever the total is. So 2,579 over the total. And your successes for the other one, for happy, would be 2,614, so the sum of those two over the total. And so that's what you might get lured into do. But again, since this is a dependent, there's different formulas. So in your book on page 476, they talk about how to calculate for dependent samples. And they're using some notation, this F12 and F21. What those are the pieces of our table that have difference of opinions. So like an F12 in our problem and an F21, they represent a success for healthy but a not happy, so a failure. So we're looking for the ones that are a success on one, then failure on the other. So this would be my F12 and F21. The 80 and the 115. So the formula to find our test statistic is add up those numbers, subtract 1, then divide by the square root of those numbers. So if we look back at our numbers again, we're looking at an 80 and a 115. So the formula says that we're going to 80 and 115, we're going to add these numbers up. Or actually subtract these numbers, sorry. So it doesn't matter which one you do first. So 115 minus 80, and then you would take the absolute value. So either way you do it, you'll get 35. We'll subtract 1. So we get 34, and we're going to divide that by the square root of their sum, which we found earlier by mistake, of 195. And this is going to give us our test statistic, 2.43 to 2 decimal places. So 2.43. And then it wants to calculate our p-value. So we will get to use StatCrunch for this one. To find our p-value is just a probability. We're looking at our test statistic is an actual z-value, so we need to look at our calculators for the normal model. I think we just typed in 2.43, right? So our z-score means 0 standard deviation 1, and let's just do a greater than. We have to consider this being a two-tailed thing. because since it's our alternative hypothesis is a not equal to, that means we have two tails. So I'd have 0.0075 to the right and 0.0075 to the left. If I take 0.0075 and I multiply it by 2, that would be my total area, giving me a 0.015. And I think they're looking to 3 decimal places for our p-value. So we'll get a 0.015. And then making our conclusion. Our alpha is 10%, we got a 1.5%. So there is sufficient evidence to reject the null because the p-value is less than our alpha. If the p is low, the null's got to go. So hopefully that helps with this one. This is again one of those different beasts. Not always are our samples going to be independent. Makes it a lot easier with StatCrunch. But in this case we have dependent, so we just have a different formula that we're working with. This guy right here to find our test statistic when we're dealing with dependent samples.